Okay, so we're going to look at a couple more examples of applied optimization where we're trying to maximize or minimize some aspect of the problem. Now here we have a rectangle that's to be inscribed in a semicircle of radius 2. What's the largest area, the maximum area the rectangle can have, and what are its dimensions? Now, if we have a rectangle inscribed in a semicircle of radius 2, then the formula for the semicircle is x squared plus y squared equals 4. Remember, you put the x minus the center x, which is 0, squared, y minus the center's y, which is 0, squared, equals the radius squared. Now, if you solve this for y, subtract x squared from both sides, and take the square root, you'll have the square root of 4 minus x squared as your y value. So if we have an x of x, and our y value is going to be the square root of 4 minus x squared. Now we want to look at the area. Now remember, the area of a rectangle is base times height. As you notice here though, this length is x, and this length is also x. From 0 to negative x is also x. So notice that the length of the base here is actually 2x. So our area of our rectangle is going to be 2x times the square root of 4 minus x squared. Now, since we know we're going to be taking an area, it would be easier to use this formula as 4 minus x squared to the 1/2, and that way we can apply the power rule. Now we're going to have to apply the power rule and also the chain rule. Since we don't have just x to the 1/2, we have 4 minus x squared to the 1/2. Okay, so we just said that our area is 2x times 4 minus x squared to the positive 1/2 power. Now, this is a product rule, so when we take the derivative, it's going to be the first term, or the first function, times the derivative of the second, 4 minus x squared to the 1/2, plus the second, 4 minus x squared to the 1/2, times the derivative of the first, which is 2x. Okay, so here we will have 2x times, and this will be 1/2 times 4 minus x squared to the 1/2 minus 1, which is negative 1/2. But remember, we just said this is a chain rule, so we'll also have to multiply by the derivative of 4 minus x squared. Plus, we'll have 4 minus x squared to the 1/2 times the derivative of 2x, which is 2. Well, the 2's are going to cancel here, so we'll have x times 4 minus x squared to the negative 1/2 times the derivative of 4 is 0, the derivative of negative x squared is negative 2x, plus 4 minus x squared to the 1/2 times 2. Now let's get this in a form we can work with. So let's go ahead and multiply the x times negative 2x is negative 2x squared. That's going to be in the numerator. If we move this down to the denominator, it will become positive. And remember, 1/2 power is square root. Okay. And this is 2 times the square root of 4 minus x squared. Now we're trying to optimize here, so we're looking for where this is 0. So where is negative 2x squared over the square root of 4 minus x squared plus 2 times 4 minus x squared equal to 0. Now I need to get rid of my fraction by multiplying everything by the square root of 4 minus x squared. So I need to go through and multiply this by the square root of 4 minus x squared, this by the square root of 4 minus x squared, this by the square root of 4 minus x squared. And when I multiply here, the square root of 4 minus x squared will cancel, and I'll have just negative 2x squared. Here, when you multiply this by the square root of 4 minus x squared, you'll have 4 minus x squared squared. Means you just have 2 times 4 minus x squared. And of course, 0 times anything is 0. That gives me negative 2x squared plus 8 minus 2x squared is 0. Or negative 4x squared plus 8 is 0. Now I want the x squared to be by itself, so I'm going to move over. Let me divide this out here. Move over my 8 by subtracting 8 from both sides. Divide both sides by negative 4. And take the square root. Now remember, normally we do plus or minus, but x has to be a positive value. Okay, so that's the square root of 2. Now, the actual base of our rectangle, since x is the square root of 2, is 2x. So one dimension of the rectangle is going to be 2 square root of 2. Okay, because it's going to be 2 times x. Now the other dimension of the rectangle was this. It was 4 minus square root of 4 minus x squared. Now if we plug in the square root of 2 for x, that's the x we found, that will be the square root of 4 minus 2, or the square root of 2. Okay, so the maximum possible area occurs when we have this a rectangle that's square root of 2 units high and 2 square root of 2 units long. Now we also want to look at an example that comes from economics. And remember, with the example we had on a previous recording from economics, you have a cost function and a revenue function. Now this shows the graph of a typical cost function. It starts concave down and later turns concave up. And it will cross the revenue curve at a break-even point. So the point B there is where you break even, where your profit and your costs are the same, or your revenue and your costs are the same. To the left of B, the company operates at a loss. And to the right of B, the company operates at a profit. The maximum profit occurs where C prime of x is equal to R prime of x. So where the derivative of the cost function is equal to the derivative of the revenue function. Now farther to the right, cost exceeds revenue again. So at some point, usually because you have rising labor costs and material costs and market saturation, production levels become unprofitable again. Now here we have a revenue function and a cost function. X represents thousands of units. We want to know the production level that maximizes profit. Now our maximum profit is going to come when R prime of x is equal to C prime of x. So I'm going to first find R prime of x. The derivative of 9x is 9. Then I'm going to find C prime of x. The derivative of x cubed is 3x squared. The derivative of 6x squared is 2 times 6 is 12x. And the derivative of 15x is 15. And what I want to know is, where are these two equal? Where is 9 equal to 3x squared minus 12x plus 15? Now first move your 9 over, subtract 9, and when you subtract 9 from both sides, you'll actually be subtracting the 9 from the 15, which will give you a plus 6. Now I can try to factor this. I can actually take out a 3. 3 times x squared is 3x squared. 3 times negative 4x is negative 12x. And 3 times 2 is 6. However, I can't go any further because no two numbers multiply to be 2 and add to be negative 4. So if I want my solutions here, I'm going to have to use the quadratic formula. A is going to be 1, B is going to be negative 4, and C is going to be positive 2. So x here will be negative b, negative negative 4, plus or minus the square root of b squared, negative 4 squared, minus 4ac, minus 4 times 1 times 2. And this is all over 2a, so 2 times 1. Negative negative 4 is 4. Negative 4 squared is 16. Minus 4 times 1 times 2 is 8. And that's all over 2. Gives us 4 plus or minus the square root of 8 over 2. Now remember, with these types of expressions, the only way that you're going to be able to simplify is if you can simplify the square root of 8. Let me come right up here. The square root of 8 is actually the square root of 4 times the square root of 2. And the square root of 4 is 2. So 8 is actually 2 square root of 2. So we really have here for x 4 plus or minus 2 square root of 2 over 2. Now since 4, 2, square root of 2, and 2 all have a 2 in common, I can factor a 2 out on the top and cancel with the 2 on bottom. So that's 2 plus or minus the square root of 2. Okay. Now 2 plus the square root of 2 is a number that is approximately 3.414. You type that into your calculator, and 2 minus the square root of 2 is a number that's approximately 0.586. Okay? Now, that's the possible production levels for maximum profit. If I actually want to know what it is, then you would want to look at the second derivative. Now the second derivative, if you take your revenue function minus your cost function and you take the second derivative, it's going to be negative at 2 plus the square root of 2 and positive at 2 minus the square root of 2. So it's actually going to be a maximum at 2 plus the square root of 2. So the maximum profit is when it's 3.414 thousandths of units, so 3,414 units.